Okay, today we are going to look about the second unit of Introduction to Data Science. If you remember, in the first unit, we talked about what is data science, and we talked about what are the four V's of the data science, what is the importance, and how it is evolving beyond the hype. And we have seen about statistical inference and how we can use exploratory data analysis to have a glimpse of what actually the data means. And then we have seen what is modeling and what is fitting a model, what is overfitting, what is underfitting. These things we have discussed in the previous unit. Now let us move on to the second unit where we talk more about data types and statistical description. So, in part of our introduction to data science, we are talking about the data, how we can describe a given data effectively so that the user can have a glimpse of what is happening, what is the data is about. So, one aspect of describing a data is using attributes. For example, if you want to represent a person, you tell his name, his complexion, his height, his hair color, his skin complexion, and then his maybe his physical features, how is his eyes, and how is his dress. All these can be called as features. Similarly, whenever you talk about whenever you save any entry on your phone, you will get attributes, name of the person, organization, then email ID, then phone number, home phone number, personal phone number, organization, office phone number. So these are all attributes. In other terms, attributes are also called dimensions whenever we talk about business analytical tools. In artificial intelligence and machine learning, the same properties or attributes are also called features. And in statistical studies, we also call them as variables. So you know that attribute represents or describes the given data entity. And the values of the attributes we observe are called observations. For example, you have an attribute called temperature. The values may be today the temperature is 20, tomorrow it is 25, then it may be 22. All these 20, 25, 22 are called observations. And when you have this set of attributes as a vector, we call that attribute vector. When you describe a data with only one attribute, generally it will not be the case unless it is very specific case. Then we call that type of distribution as univariate distribution. And if you describe any data with two attributes, we call that as bivariate distribution. Now we are going to see what are the different types of attributes. Firstly, there are nominal attributes. Then we are going to see binary attributes, ordinal attributes, numeric attributes, and some more very less significant other attributes also we are going to see. So firstly, let us talk about nominal attribute. Nominal attribute, as the name indicates, it's related to the name of an attribute. For example, colors. Every color has a name. So color is a nominal attribute. Similarly, you can have, let us say, BTech stream, computer science. Then after artificial intelligence, machine learning, data science, information technology, all these are nominal attributes. Each value will represent some kind of category, code, or state, and because they have a different category, they are not continuous. Everyone is a separate entity. That's why we call them as categorical. They may not have any meaningful order. For example, I cannot say that red is more valuable than green or green is more valuable than blue. I cannot say that, but they are all distinct categories. We also call them as enumerations. So colors, then marital status, single, married, divorced, widowed, then gender is a nominal attribute, then uh, country is a nominal attribute, then mother tongue is a nominal attribute, then nationality is a nominal attribute. These are all nominal attributes where we have the names or discrete names. Then secondly, first one, nominal attribute. Second one is binary attribute, which has two values. You know the meaning of binary, right? Binary has two values. One is it may be 0 or 1 or 2, maybe anything, true or false. Generally, true is indicated by 0 and false is indicated by 0. True is indicated by 1. So, suppose you are dealing with a machine learning problem, you want to classify whether a given person has cancer or not, then that is a binary classification problem. The answer will be 1 or 0. 1 means he is affected by cancer. 0 means he is not affected by the cancer. So these are binary attributes which has only two values. If both values are equally valuable or equally prioritized, we call that attribute as symmetric attribute. For example, gender, only two values, male and female. Then we cannot say that male is more important than female. So gender is an symmetric attribute. Sometimes one value may be more desirable than the other value. For example, you are talking about that you are testing whether a person is affected with cancer or not, then the desirable value is not affected, that is 0. Then it is asymmetric. We don't want one value with equal probability. So binary attributes are divided into two categories: symmetric, asymmetric. The third category is known as ordinal attributes, where the attributes are ranked. They are arranged in a order. For example, you buy a T-shirt. When you go to showroom, you look at the size. There will be small, there will be medium, there will be large, there will be XL, then there will be double XL. So there is a meaningful order. We say that small is smaller than the medium, but at the same time, we cannot say how much small it is. Even for your grades, if you take A plus, A plus plus, A plus, A, B, C, O, all these are this. Another example is professional rank in any college or university. Faculty are categorized as assistant professor, associate professor, professor, senior professor, full professor. Yes, for example, in our Indian Army, you take lieutenant, captain, major, lieutenant colonel, colonel, brigadier, major general, lieutenant general, general, field marshal. All these are ranked. Even in police department, you see constable, head constable, sub inspector, circle inspector, deputy superintendent of police, then superintendent of police, or ACP, DCP, then CP, then IG, DIG. So all these director general, DGP, that is the highest rank. Generally, these ordinal attributes are used in customer service satisfaction or given review rating, 0 very dissatisfied, 4 very satisfied, something like that. Whenever you go to any restaurant or movie, the people ask for feedback to give on scale of 0 to 4 or 0 to 5 or 0 to 10. So these are ordinal attributes where there is some order of the attribute. Then we have fourth category, numeric attributes, which are measurable, they are numbered. For example, what is the temperature today? That is a numeric attribute. What is your height? That is a numeric attribute. How many marks you got in a particular subject? That is a numeric attribute. Then what is your weight? That is a numeric attribute. So it can be any numerical values. When we talk about this, there are two categories of numerical attributes. Uh, we call them as what we have seen so far. Firstly, uh, we talked about nominal attributes, where we have the names categorized. Then we have seen binary attributes, which are two values which are divided into, if both values are equally important, then it is known as symmetric attribute. If that is not the case, it is known as asymmetric attribute. Then thirdly, when you have an order, rank-wise order in the attribute, then it is known as ordinal attribute. And the fourth one we are discussing are numeric attributes which have a value. So, what are numeric attributes? Temperature today, rainfall today, how many runs Sachin has made, all these are numeric attributes. Numeric attributes can be divided into two categories. One is interval scaled attributes and ratio scaled attributes. Suppose your measurement, you are measuring some value. For example, you are measuring height. When I say height is 5 feet. What mean by 5 feet? If the height is 0, then that is 0.0 feet. From 0, you have measured 1 feet, 2 feet, 3 feet, 4 feet, 5 feet. So 0 means no height. No height. So if I say, suppose a person has 3 feet, he is of 3 feet height, then another person may have 6 feet height. So I can say that the person X who has 3 feet or Y who has 6 feet, this person as a height is twice of the height of the person of X, because this scale is starting from 0. We can, without any hesitation, I can say that 6 by 3 is 2. So because it is starting from 0. But if suppose you have temperature in centigrade scale, this is 0, this is 5, this is 10. I know that 0 to 5, the difference is 5, and this is 0 to 5. But the problem here is I cannot say that at 10, the heat at 10 is double of heat at 5. I cannot say that. Why I cannot say that? Because 0 means, it doesn't mean that there is no temperature or no heat. Even you can have a temperature of -1, -2, -3, so on. So because your temperature 0 doesn't mean that there is no temperature, I cannot say that. So this type of attributes where you can have ratio is known as ratio scaled attribute. And this type of attributes where you can quantify the difference, but you cannot use them as ratios, is known as ratio scaled attributes. So degree Celsius temperature scale is interval, uh, this is interval scaled attributes. You cannot use them as ratio, but here you can use them as ratio scale. So what we have seen, nominal attribute, binary attribute, ordinal attribute, numeric attributes. Numeric attributes, two category, interval scaled, ratio scaled. If your scale starts from 0 and 0 means there is nothing, then it is ratio scaled. If your temperature, if your scale starts from 0 but 0 doesn't mean that there is no value, then it is interval scaled attribute. Then another category of attributes is discrete and continuous attribute. Discrete means category. For example, gender is a category, male, female, that is a category. Uh, it is something like a separate set of values. And continuous attribute means it will have continuous values. For example, temperature. If you take, suppose you take grades. Grades, they are A, O, A, B, C, D. These are discrete. When you plot them, you have a separate value. This is a discrete graph. Whereas continuous, for example, you take the temperature. When you plot the temperature, it is continuous. So when I say temperature, it may be 20, it may be 20.1, 20.2, 20.3, so on. It will take any value. It is all these are continuous values. When you talk about grade, it is either A or B, not in between A and B. So this type of attributes, which we have a definite set of properties, are known as categorical attributes, and these are known as continuous attributes. Categorical attributes, continuous attributes. What will be the temperature tomorrow is a continuous attribute. Tomorrow India will win a cricket match or not, that is a categorical attribute. So in machine learning language, when we deal with categorical attributes, we call that problem as classification problem. And when we deal with continuous value prediction, we call that as regression in machine learning language, regression. Going further, so these are the categories of attributes that we have seen. Firstly, we have seen binary nominal attributes. Then we have seen nominal attributes, binary attributes, ordinal attributes, numeric attributes. In the numeric two categories, interval scaled attribute and ratio scaled attributes, discrete and continuous attributes. This is about with these attributes we can describe the data. We can describe the data. For example, I have medical data of persons. What will be the attributes? BP, blood pressure. What blood pressure, what type of attribute it is? It is numerical attribute. It will have a value, and it is continuous attribute because it may be having sequence of values. Then diabetic, whether patient is diabetic or not, that is a binary attribute. If you take only two values, that is a binary attribute. Then weight, that is a continuous attribute. Height, that is a continuous numerical attribute. Gender, it is a binary attribute. So you can describe the data with different types of attributes.